you can take one as an assignment question and try this. Okay. The question is assignment. Write a program of behavioral model of 4-bit shift register. You know what are the shift registers, right? Shifting that bit data by flip-flop to flip-flop, bit by bit, right shift operation and the left shift operation. Okay. 4-bit right and left shift operation. So can you think of this, how to solve this problem? Right and left shift operation. What is shift register? Shift register, suppose I am talking about 4-bit shift register. 4-bit shift register. How many flip-flops are required to configure this? 4 flip-flops, correct? So let us take this is 1, 2, 3 and 4. The type of clock I am going to connecting is a synchronous clock, correct? So how to configure the shift register operation? Left shift means data is shifted from what? Left to the right. So that I should give the input here. Serial input here. Output of input to this flip-flop. Again, output of this is feeding input to this. Output of this is feeding input to this. Correct. This is the final output. Let us take output of this is QA, QB, QC and QP. Correct. If I load the data 1, 0, 1, 0, our data is shifted to the right shift. Tell me the right shift operation. Initial state, let us take QA, QB, QC and QD. Correct. So this is a clock. At initial clock 0, let us take this is 1, 0, 1, 0. The next clock comes. What happens? Data should be shifted towards right means what? This is shifted to the 1, this shifted to the 0, and this shifted to the 1. And next clock, this is 0 here, this is 1 here. Again, next clock, this should be shifted here, and this 1 shifted here. Correct. Yeah. Next clock, 1. So this our data will be shifted to the 1. Right. So I want to configure this. This is a right shift operation. How to configure the left shift operations? So data should be input to here, correct? Input is here, and then shift the bit by bit to towards the left. So how to model this using conditional statements? Think of this question. I want to model this using conditional statements. The program is write a program of behavioral model of 4-bit shift register. 4-bit right or left shift register using what statements? Conditional statements. How to write using conditional statement? Conditional statements. How to model this? Let me write the design file, then you try with the test bench to this. Correct. So module, correct? Module is, let us write shift register as a module name. Shift register is a module name. What are the inputs required to this, to model this shift register? Clock is one input. Then I can use a reset. When reset is you decide that always all the flip-flops to 0. Then you need what? I want to do both the left shift and right shift. Then I need a mode control. Mode operation. Mode is 1, do the what? Right shift operation. Mode is 0, left shift operation. Shall I take the shifter? Shift is the input. Then Q is the output. Correct. Q is the output. Then what are the inputs are in this case? Input are clock, reset, then shift. Then output are, how many bit output we are designing is 4 bit, 3 down to 0 or Q. Correct? Output, now we are writing the behavioral model. Output is range. Next, what I want to do? Always, then event. What event we can write? Decide that whenever pass edge comes, data should be shifting. Pass edge, clock, begin. Okay, then what I want to do? A, my reset, begin, what I want to do is equal to what? 0. So to shift the data, we need to initialize the data to the shift register. I'm going to use Q is equal to what? Porting B. Let us load this data. Initial 1010. If reset is equal to 1, what I am doing? Q is equal to 0. Else. Now end this. End. Again else. What I want to do? Else begin. Correct. What I need to do in the else begin? The else begin, we are going to write the body. Correct. We are going to write the conditional statement that if shift, correct. If shift is equal to 1, what I want to do? Let us decide that we can do to the right shift. What is the right shift operation? What is the right shift operation? How shifting of data will take place here? QD is equal to what? QC. What is QC? QC is equal to what? QB. QB is equal to what? QA. And QA you can take it as 0. Now this is nothing but a right shift operation. Did you understand? Now what I need to write here? What I need to write? Q of 3, correct? I'm declaring this as a vector. Q of 3 is equal to what? Q of 2. Then Q of 2 is equal to what? Q of 1. And what is Q of 1 is? Q of 1 is equal to, so I'm taking this is Q3, Q2, this is nothing but Q of 0. Again, Q of 0 is equal to what? 0. Did you understand? If shift is equal to 1. Else, correct? This is end here. Next, what I need to do? Else begin for this. Else, if shift is equal to 0, what I want to do? Left shift operation. Here, shift is equal to 1, what will happen? Doing the right shift operation. The shift is equal to what? 0, what I want to do? Left shift. How to write the left shift? Q of 0 is equal to what? Q of 1. Q of 1 is equal to what? Q of 2. Again, Q of 2 is equal to what? Q of 3. Again, Q of 3 is equal to what? 0. Correct? Now I am going to end this L. Now I am going to end this LC. Correct? Next, what I need to do? I need to end the always. Then I need to end the what? Module. End the module. Did you understand this? Now this is a behavioral model of conditional statement for the shift register. You can write test bench to this and verify the shifting of data. Did you understand? So this is your model using the conditional statement. Shift register using conditional statement. Okay. So now let us begin with multi-branching statement. In Verilog, what are the multi-branching statement is supported is? What is the use of this multi-branching statement? Multi-branching statement. So this is an alternative to the nested if. If there are many alternatives are there in nested if, that you can done through multi-branching statement. So this is alternative
अब खाना खा रहे हो?
to the what?
2 मिनट ले लो, 2 मिनट रुक जाओ।
Nested if statement.
मेरे को खाना खाने दो, मैं देता हूँ आपको।
Nested if statement.
नहीं ले लो
There are
ले लो।
many.
मैं आ ही रहा हूँ, बाहर आ
There
रहा हूँ।
are 100 else if statements are there. Whether could you able
ले लो
to
ना।
doing this if statement is bulky. So what you can do, you can go with what? Multi-branching statement. The multi-branching statement in the Verilog supports case statement. Okay, this is a case statement. Case X statement and the case Z statement. Case Z statement. If you see the syntax of this, syntax of the case statement, how to write the syntax of the case statement? What are the keywords are used to do the case statement? Case and write the what? Express to this case statement. Expression, correct. Then what I want to do? Then I need to write the alternatives to this. Okay, expression. This is an alternative, and write the statements. Alternate 1, like alternate 2, okay, alternate 3, so on. And also this case statement will be having a default. If these alternatives are not true, then it will go to what? Default statement. Default statements. Again, this is a default statement. And this case statements will be end with the what? Keyword is end case. End case. The keywords for the case statement is what? Case, end case, correct. Default. Default. You don't understand. Now let us write a simple program for this, then we'll understand. So before that, we'll do one thing. Let us understand what is this multi-way branching case statement. So what is the use of this multi-branching case statement is nothing but the nested if else statement can become unwieldy if there are too many alternatives. There are many else if statements are there. This becomes very unwieldy if there are too many alternatives. The shortcut to achieve the same result to use the what statement? Case statements. The keywords for this case statement is case, end case and default. Default is optional to the case statement. Okay. So are used in the case statement. A block of multiple statements can be grouped by using the begin and end. We will see this one. Okay. So what is the syntax of the case statement? Start with what? Case. Then parenthesis, you are writing the expression. This is the alternate one. Then this is nothing but what? Statement 1. This is what? Alternative to statement 2. If alternate 3, statement 3, like so on number of alternates. If there are cases. If this is true, suppose if alternate case 1 is true here, expression is true, it execute what case? This case. Did you understand? If this expression is true for alternative 2, then this case will be executed. Did you understand? Huh? So here, the default is optional to the case statement. This case will be end with the keyword is called it as what? End case. Okay. And a block of multiple statements will be grouped by what? Begin and end. Suppose your statement, this statement 1 will be having a multiple blocks. Like multiple blocks, like if it is A plus B or Z is equal to B minus C, these are the statements. Then you should group it with here what? This alternative group with what? Begin and end. If this is a single statement, no need of grouping with what? Begin and end. So a block of multiple statement must be grouped by what? begin and end. Begin and end. You understand? Now let us write a very simple program to understand how this case statement will work. Then we'll take up how to model the flip-flops, how to model the counters using case statement. We'll go, and then we'll go with what is the use of the case Z and case X statements. Okay. Now what is a case? How you can write a syntax to the case? Suppose I'm asking a program to write a program of arithmetic operations. Let us take arithmetic operation. So what are the arithmetic operations are there? Addition, subtraction, multiplication, division, exponential, log operation. Those are extension of the arithmetic operations. Correct. Now let us do 4. Addition, subtraction, multiplication, and the division. Then using case. Write a program of arithmetic operation using case statement. Case statement. How to write a program to this case statement using case statement? First, let us define the module, correct? Module, TB, okay. Then let us declare the integers. So I'm using the variables. But variables I'm declaring this as what? Integer. Let us take integer a, comma, b, comma, c, comma. Let us declare the 4 integers. Then what I need to do? How to use the case statement? What are the statements I can use this multi-branching statements? Means what are the procedural? We can use this is using what? Procedural statements like initial, begin and always begin. Initial, begin and always begin. You can use the multi-branching statements. Now I'm going to write a program to check or designing of arithmetic operation. Shall I go with initial, begin? Initial, begin. Then what I need to do? Case statement, case. Case, then what I need to do? Expression. Or shall we write the design file to this? Or test bench is enough to this? Test bench is enough to this. Then what is the case expression is? Case expression I want to do. If this case expression is to respective cases should be executed. Correct. So let take case as ALU underscore control. ALU underscore control. So this I can declare as a what? Range means suppose range. If I declare the range, I can execute only 2. Correct. So let us declare this range as 1 down to 0. Correct. ALU underscore correct. Control. Now this control will take ALU control will take how many bits? 2 bits. 0 0. Correct. I can put 0 0, 0 1, 1 0 and 1 1. Now when this is 0 0, what statement I should execute? What is the alternative I should write for this? What is the alternative? Alternative I can write 2 tick B 0 0 means what is this is? Alternative 1. If 2 tick B 0 0, what I want to do? Let us decide that I want to do addition operation. Let us take D is the output variable. So D is equal to, or let us take C. C is equal to, what I am going to do is nothing but addition operation. This is a statement I am writing. What operation I am doing? Addition. When ALU control is what? 0 0. When it is 0 0, this case will be executed. Are you understand? Next, what I can do? Next alternative is nothing but what? 2 tick B 0 1 colon. What I want to do? Let us decide subtraction. A is equal to C is equal to 1. A minus B. Right. Again 2 tick B 1 0. What I want to do? C is equal to, let us do correct. 2 tick B 1 1. What I want to do? Let us decide division. A divided by B. Correct. Did you understand? Let us write a default statement to this. What default statement I can write to this? Default. If ALU is 0 0 addition. 0, 1 is subtraction, 1, 0 is multiplication, 1, 1 is division. Other than if I give, if ALU I'm giving as XX or ZZ input, what I have to do? Invalid. So I can write dollar symbol display. Dollar symbol this statement, what I'm going to write is nothing dollar symbol display, invalid input to the ALU. Is it fine? Are you understanding? So I can write invalid to the ALU underscore control input. Did you understand this? Then what I need to do? In the case. Is it clear? In the case, then what I need to do? In the initial, in the module. In the module. Now I need to initialize the data right here. So shall I initialize the data? Let us take A is equal to 10, B is equal to 2. So I don't need D variable. Let us remove this D variable. I'm not using the D variable. I'll remove the D variable. So this is a case statement we are writing what arithmetic operation, addition, subtraction, multiplication. Now I want to monitor this. So how to monitor this or how to print the outputs? Let us go with what? Initial begin. Shall I generate what? A is already generated. I'm going to generate what? ALU underscore control. Or I can write, I don't need a concatenation here. ALU underscore control is equal to what? Dollar symbol random. Shall I do like this? Okay, let us give some simulation time. Then I'm going to monitor. Or I can go display. Display of what I need to display. It has display the time. Okay. Then /t. What I want to display? A I want to display. A is equal to percentage D. Okay. B is equal to percentage D. C is equal to percentage D. Then what I need to do? I need to pass the argument. What are the arguments? A comma, B comma, C. Then let me finish. Finish. Then I am going to end. And I am ending the module here. Are you understand? Now let us run this program. So I am getting the output for this. But I am getting here C is equal to at time 5. What I am using here, control, color symbol random. Let us print this control also. ALU underscore control is equal to, let us print this in the percentage B. Now I am going to print 0D, 0D, 0D. Now when ALU is 0, 0, here I am declaring this ALU here, dollar monitor. So we need to pass the argument. ALU underscore control. ALU underscore control. Correct. Now let us, now that is what I am getting, missing the argument. I have not passed the argument. Now you can see ALU underscore control is 0, 0. A is 10, B is 2, but it is executing what statement? Default statement. What is default statement I am writing is invalid to the ALU control input. Can you check the program? So when a control is 0, 0, ALU control is 0, 0, what I have to do? I have to do addition operation. So let us repeat this program. Repeat 5 times and begin. Can you see where we have done the mistake in this program? I'm going to finish after the repeat. Okay, this is for n, this n for the repeat, then I'm going to finish. Again, I'm going to do here. Okay, then I'm ending the module. Okay, now let us repeat this for 5 times. But it is not doing ALU, it is taking 0001, 1101. A and B value is taking to A is 10, B is 2.
क्या हुआ बा?
But C is taking as 1. X.
हैं?
But A0, ALU 00, which statement you should execute? Addition should execute. Can you see what is the mistake we have done in this program? Now we have declared the integer ABC. So Reg, we are taking ALU underscore control, initial begin. Now we are initializing the A is equal to 10. Or I can generate the A and B value here itself using concatenation. Instead of writing A is equal to 10 and B is equal to 10, let us go with what? Concatenation. I can write A comma B comma close this. Correct. Now dollar symbol random I can write. Now in this case,
First,
A is
he is
taking.
out.
चुनाव का किसका रुझान है लोगों में वो हम जानने की कोशिश करें। बताओ। देखो भैया हमारा तो फतेहपुर से है और फतेहपुर से सरवण चौधरी की तरफ है पूरा।
In the
बीजेपी निकलेगी फतेहपुर से। और मुख्यमंत्री कौन बने?
default statement.
हाँ मैं
As
दो रोटी और है, दो रोटी और खाए हैं। आप उधर हो तो टेंशन क्यों
Now
कर रहे
in this
हैं?
case,
Yes.
my case here.
Sir.
Yeah, hello.
हाँ हाँ तो आप
He is output. We can
Yeah.
declare in white.
So we are writing the test bench to this, correct? Test bench to this.
Yes, sir. C in white, sir. declared in white.
बीजेपी के आप समर्थक हैं और मुख्यमंत्री अशोक गहलोत के साथ। बिल्कुल।
C is the white data type.
अच्छे काम कर रहा है, बहुत अच्छे काम किए उसने।
But I am not modeling the hardware right here. Why I should declare C as white data type?
अगर हंसना है तो हम 2 मिनट के लिए अभी बोल
See, I am just doing control case statement I am using to do operation, arithmetic operation. I am declaring ABC as an integer. If I am using this C as a is file, in my test bench I should declare that as a output as declaring as a white data type. So I am not writing any design file here. The test bench in initial begin I am writing this control step, case statement. Okay, can you figure out the mistake?
फतेहपुर के लिए पूछ रहा हूँ मैं। बता दिए आपके फतेहपुर के सांसद ने क्या किया।
Let me debug one by one in the case statement. When ALU is equal to 0, 0, 2 tick B 0, 0 is nothing but A plus B it should happen. Let us take this is U random inside number of A and B. So it is taking very big number. Okay. Let us write the ALU underscore control is equal to dollar symbol random. Let us initialize A to 10. I mean the smaller number I'm giving here, that's it. If I go with the dollar symbol random, it is taking very big number. First let us work with the smaller numbers, then we go with randomization of this.
डालते पार्टी है तो कोई संसद तो क्या वोट डालते टाइम पे सोचते होगे ना कुछ क्या ऐसे ही बस बटन दबा के निकल गया वापस।
Okay, let us check this case step. Case, I'm writing the ALU underscore control. It is a 2 tick B of 0, 0. C is equal to expression A plus B. Now we have declared the input area. So let us see. This is a program we write exactly. Case ALU underscore control. 2 tick D.
आपका नाम क्या है? मोहम्मद अली नाम है।
This is 0, 0. Okay. Mistake done is nothing but let us make this is 2 tick. Instead of writing into the binary, let us make this is what? 1. This is 2. This is nothing but 3. Okay. If ALU, whatever the value of ALU it will take, line number. Now line number it is taking ALUs and declaring as a 1. That's right. Now 1 means it should take the value will be 2 tick. I should declare this as a decimal. Correct. This should be the decimal. Now let us go. 2 tick D. C is equal to A plus B. 2 tick D1, D2. Case statement I am not using begin and end. If here I have a multiple statement, say for example, if I have a multiple statements here I should need a what? Begin and end. Okay. So this is syntax of the ALU. ALU control symbol. The case ALU control to take D0. So we are doing addition operation, subtraction, multiplication. We are writing the word like a default statement. Then we are ending the case. So we are declaring ALU underscore control is a registered data type. Okay, let us debug this program. So by default, this integer C is getting an unknown state. One second, let me try this. It's range
बाबा
7 down to
चल जा।
0. A
कोई बुला रही
comma,
है
B comma,
उधर
C.
उधर निकलो फटाफट।
Why this is taking?
तो अब मम्मी अभी बुला रही है। भीड़ नहीं है होता है। भीड़ नहीं है वहाँ पर।
भीड़ नहीं है।
हाँ। जल्दी दे क्या करोगे? पर चल अपना मम्मी बोली आईडी कार्ड लेके आना।
मैं जाऊंगा तो पूरे तैयारी से जाऊंगा।
जल्दी जाओ तुम बैठ के आया तो बात देना।
हाँ मैं जा
Integer 1 down to 0. ALU initial begin.
ले तो रहा हूँ तब हम
It started with the case.
देखो जल्दी निकल जाओ जल्दी से आ जाओ जल्दी जाके।
वैसे जाऊंगा सामान दे
Now the initialization can be done with, so in the procedural statements. Let's try this once. Invalid module instantiation for this. This I should declare. Okay, that's the initial beginning. Let us make A is equal to 10, B is equal to 2, then end. I'm using one more initial block to initialize the A and B values. See. Is taking invalid. Okay, let me do one thing. So let us make a test bench to this, a design file to this. Then we'll write a test bench to this. Okay. So now module TB. So in that case, inputs are A and B, correct? So let us write. This is, let us take ALU. So what are the inputs are? A comma, B comma, C. Here input A comma, B. and output C. Output is C. Then what I should do? This I need to change what? Always at the rate, just write the star. Always at the rate star. I'm writing the what? Behavioral model to this. Always begin, then I'm using the case statement. AC, ALU underscore control. Then this is a case statement. Then I'm going to end the case. In the always. Now I'm going to end the module. In the module. Okay. Then I'm going to write a test bench to this. Module. What is the test bench to this? Module TB. Range of what? So let us declare range as what? A comma B. Let us take 4-bit of inputs. 4-bit of inputs. 3 down to 0 of what? A comma B. Here I am going to declare range what? 3 down to 0, A comma B. Then I should declare this as a output also. I am going to make 3 down to 0. Okay. Output range this is. Output range 3 down to 0. Now here while this is what? 3 down to 0 of C. 3 down to 0 of C.
Screen is not with.
Yes. Can you check screen is visible now? I've shared the. Can you check your net connection? Now I'm going to write the initial begin. Now I need to instantiate, right? So what is the name I'm giving is ALU. Then this is DUT of. Shall I go with dot star? Port connection by default. Then initial begin. Now I'm generating the what? Let us generate the random values A comma B comma C. C is not important. A comma B comma ALU underscore control dollar double van. Now I'm printing on this. Is it clear? Now I'm generating the random value timestamp. Then I'm printing the ABC values. Okay, ALU control also input. Let us write ALU underscore what? Control. So this is input or output? This is input. How many bit input it is? To control. To underscore control. Then I have declared here in the test bench. This is also what type? Page type 1 down to 0. ALU underscore control. ALU underscore control. Now this part of program is initial begin. So we are initializing the ABC, AB and ALU underscore control. Then we are printing the output. Now that has done this program. 4 plus 9 is nothing but what? 13. So now we are getting the output for this. So at t is equal to 5, ALU 0, 0. When it is 0, 0, what case I need to execute? This case should be executed. A plus B. What is the A value is? 4 and B value is 9. 4 plus 9 is 13. Then 0, 1, what is this is? A minus B. 10 minus 0 is nothing but 1. 10. In 0, 1 means what? Again it is a subtraction. 8 minus 2 is nothing but 6. Again 1, 1 is nothing but division. So what is the division I am doing is? So 9 divided by 8. Remainder is nothing but 1. Correct? 0, 1 means what? Subtraction. 12 minus 3 is nothing but 1. 9. Correct? Did you understand this program now? How to use the case statements? If my control is X or ZZ, what it is going to print? It is going to print the default state. So input to the ALU is invalid to the ALU. Did you understand how to write a case statement? So now using this case statement, can you model the flip-flops? JK flip-flop, SR flip-flop, T flip-flop and T flip-flop using case statement. How to model this? Okay, first you understand that how this case statement works. Did you understand? In this case, when ALU control is 0, 0, what it is going to execute? This. What is the alternative I am writing is? 2 tick D means what? Decimal. So decimal 0 means is 2 bits. Decimal 0 means ALU underscore control is 0, 0. When this is 0, 0, this statement will be executed. What is this statement I am writing is C is equal to A plus B. Okay. When ALU underscore control is 0, 1, second statement will be executed. So 1, 0, third statement will be executed. 1, 1, this fourth statement. Division will happen. If ALU is other than 0 and 1, what statement it is going to execute? Default statement. So use the case statement to model the JK flip-flop. How to model the JK flip-flop using case statements? Can you write a program to this quickly? You understand how to use this control set, case statements to do this. What is JK flip-flop is? What is JK flip-flop? If J0, K0, what is operation? Memory operation. Q follows the Q. 0, 1, reset operation. 1, 0, set operation. 1, 1, toggle operation. So how to model? Okay, let us take a problem. So write a program of behavioral model. Behavioral model of JK flip-flop. JK flip-flop using case statement. Using case statement. How to write this? Module, correct? What is module name is? JK flip-flop. So write the JK flip-flop. Clock required J, K, and then Q, Q bar. Q bar. So I am taking in this case reset is optional. If you are using reset, if reset is equal to 1, make Q to 0. Reset is equal to 0. Again in the else you write the case statement. How do you understand? Now what are the inputs in this case is? Input, clock, J, K. Output writes Q bar. Then always let us take at the what? Pass edge of the clock. Pass to edge of the clock. Begin. Then what I need to do? Always at the positive edge of the clock begin. Now we should start writing the case. Correct. To write the case, how to write the case to the flip-flop? Case. What is the expression I can write? J and K. Correct. J and K shall I use the concatenation? What this operator will do? Curly braces is a concatenation. I can write what? J comma K. If J0, K0, what do you want to do? Q is equal to Q. Memory state. J0, K1, reset state. J1, K0, set state. 1, 1, toggling operation. Now what is the alternative I should write to this? What is the alternative? To tick or B0, 0 also fine, right? If I write in binary 0, 0, what I need to write? Q is equal to what? Q. Correct? Q is equal to Q. So initially shall I declare Q to what? Shall I declare the Q to 0 or 1 tick B0? Is it okay? Then Q bar to what? 1 tick B1. 1 tick B1. Now when J0, K0, what I am doing? Q is equal to Q, memory state. Now to tick B 0 1.
नहीं वो ऐसे कहता
What I
है,
want to
जैसे
write?
मान लो कि 15 लाख देता
Q is equal to what?
15 लाख अपन कैश थोड़ी दे सकते हैं उसे।
One tick, correct? B
जमीन पर तो
B 0. Next to tick B
5 लाख
1 0.
मतलब ऐसा हो तो
What I want to do? Q is equal to 1 tick B1.
तो देने वाला वो पूरा
Correct?
करेगा।
Again 2 tick B 1 1. What is Q should be? Toggling out. Toggling means what? Not of Q. Not of Q. Then you can take a default. If other than JK is other than 0 1, then you should print like a display, like invalid inputs to the JK flip-flop. Right. Let us take default. Default. What I can write? Dollar symbol display. The statement to this I am going to write. So I'll write invalid to the what? JK inputs. Then I'm going to end this. Now what I need to do? End the case. Clear. So I'm going to write here Q bar is equal to what? Not of Q. Q bar is equal to not of Q. So when this cases comes 0 0, memory state, reset state, set state, toggling state, then Q bar will follows what? Not of Q. Then what I need to do? End the always begin. Correct. In the always begin, then in the module. Now let us check for what? Syntax errors. Now there is no syntax errors to this. Now can you write the test bench to this program? What is the test bench? Module, PB, reg, clock, correct? J comma K. Then where is what? Q1, Q bar. Then I need to initialize the design. This is DUT R. So let us go by what? Connection by name I am going to. So this is dot clock of what? Clock. This dot J of J. This dot K of K. And the dot Q of Q. And this is dot Q bar of Q bar. Then what I need to do? I need a clock. Will I generate the clock to this? Clock is equal to what? Not of clock. Then initial begin. Initialize the what? Clock to 0. Correct. Then shall I randomly generate the value? How to generate the random value? J comma K is equal to what? Dollar symbol. Is it clear? Then let us give some simulation time. Then what I can do? Display. Display of what I need to display? Dollar symbol time, comma, double quotes. Let me give the tab space. J is equal to what? Percentage B, comma, K is equal to percentage B, comma, Q is equal to percentage B, comma, Q bar is equal to percentage B. Percentage B, what are the argument I need to pass? Clock, J, K, Q and Q bar. Yeah. So we are not, not writing the formatted string. Clock is equal to what? Percentage B. Clock J and Q bar. Then let me give the finish time. 100. Dollar symbol finish. Then I am going to end. Then what I need to do? End the module. So shall I repeat this? Repeat the 5 times or 10 times. I am going to repeat. Repeat of. Let us repeat for 10. Begin. Begin. Then let me end here. Before finish, I am going to hit the repeat. Then I am finishing. Then I am ending the module. Okay. Now we have done the JK flip-flop using what model? What structure? Using the multi-branch case statements. Now let us run this program. So we are getting the output for this. Let us analyze this output. So at the clock 5, t is equal to 5 initially.
Hello.
So we are changing at what time? Simulation time is dash 5. At dash 5, what is my clock is? 1.
Hello.
J0, K0.
Hello. Hello.
What is this state is? 0, 1. Again, 0, 1 means 0, 1 state. 1, 1 means what it is operation? Toggling operation. Toggling operation means if the previous state is 0, Q is 0, but Q bar becomes 1. If it is 0, 1 means what? Memory state. Correct? Sorry, reset state. Again, all these three are reset state. Here 1, 0 means what state it is? Set state. Here this is nothing but what? Again, this is nothing but reset state. Again, this is nothing but reset state. Did you understand? Now this is modeled as a what? JK flip-flop. Did you understand this program using case state? So when the case J is 0, 0, memory state, 0, 1, reset state, 1, 0, set state, 1, 1 is nothing but toggling operation. So we have the same thing using conditional statement also. Using case also, you can model the JK flip-flop. Did you understand? How to do SR flip-flop? How to do SR flip-flop? What is SR flip-flop? SR 0, 0 memory state. S0 R0 memory state. 0, 1 set reset state. 1, 0 set state. 1, 1 is invalid state. So what I have to do here? I need to model SR flip-flop. SR. This is what? Now S input. This is R input. Again inputs are S and R. Same program, correct? Here I can write what? S and R. So here I need to print. This is S and. Here inputs are SR, but in case statement when both are 1, what I need to do? Invalid state. So what I can write? 1 take B of what? X. 1 take B of X, correct? Then this is S and R. Here I need to pass the argument. Sorry, port connection by S to S, correct? R to R. R to R. Then here I need to print, generating the S and R value. This is S and R. Again here I need to change this into what? S. This is R. And what argument I need to pass? I need to pass S and R. S and R. So rest of the things are same, correct? Line number 24. So we need to instantiate SR and then need to change this as what? SR. Okay. Now let us run this program. See, let us see this output. At the clock 1, S0 R0 means what? Memory state. 0, 1 means what? Reset state. Again 0, 1 is reset state. 1, 1 invalid state. 0, 1 reset state, reset state, reset state. 1, 0 means set state, reset state, reset state. Is it clear? So how to model this using what statement? Multi-branching in that case statement. Is it clear this program? Now can you model the 4x1 multiplexer using case statement? So take a problem. Write a program of 4 cross 1 mux. 4 cross 1 mux. Write a behavioral model. Write a behavioral model of 4 cross 1 mux. 4 cross 1 mux using case statement. Write a program to this. How to model case statement? Module. So shall I take module name is mux 4 cross 1. What are the inputs are? Let us write I comma s comma y. Then I need to declare input. Correct. This is what? 3 down to 0 of what? I. Then output. Okay, one input, right? Select line we have 1 down to 0 of 1. Yes. Then output reg. This is what? Y. Output reg y. Then always at the rate. What is the event I can write? If I of 0 R. So event R control you can write for this, right? Combination logic circuit. Or you can write a positive edge. So whenever positive edge comes, so based upon your select line, it has to assign the output to the input. Data selection should happen. So for the combinational logic circuit, I can use this stuff. You can begin, then case of what I need to write. Concatenation right here. Okay, I can write S because I am declaring S as what? Vector. I can write S here. Yes, you are correct. Correct. If I am writing S of 0, S of 1, then I should go for the concatenation. Then, what is alternative one is? To tick B 0 0, what I need to select? Output Y is equal to I of 0. I am declaring this as a what? Vector. So I of 0. Then, to tick B 0 1, Y is equal to what? I of 1. Then, to tick B 1 0, what is Y is equal to? I of 2. I of 2.